from the pinhole is 10 cm. We are asked to calculate the height of the object X. Image in plane mirror. The number of images n formed in two mirrors inclined at an angle theta is given by n equals to 360 over theta. In bracket, if 360 over theta gives an odd number, n equal to 360 over theta minus 1. If in bracket, if 360 over theta gives an even number, when theta is equals to 90 degrees, n is equals to 3. When theta is equals to 60 degrees, n is equals to 5, and so on. Example 1. Calculate the number of images formed by two mirrors inclined at an angle 90 degrees to each other. The object is 1 unit distance from each mirror. Solution. N is equals to 360 over theta minus 1. N is equals to 360 over theta minus 1, which will give us 3. Therefore, the number of images formed is equals to 3. Curved mirror formula. 1. Relationship between radius of curvature r and focal length. R is equals to 2f, or f focal length is equals to 2 over r. 2. Object and image relationship. 1 over u plus 1 over v is equals to 1 over f. 3a. The lateral image magnification m is given by m equals to height of image over height of object. 3b. Linear or transverse magnification m is given by m equals to image distance v over object distance u, which is equals to v over u. 3c. M magnification is equals to height of image over height of object equals to image distance over object distance. Sign rule. Real is positive RP. The distances of a real object or image from a mirror are given positive sign. If they are virtual, the distance are given negative sign. Remember that concave mirror F is positive, convex mirror F is negative. Example 1. An object is placed 30 cm from a concave mirror of focal length 15 cm. Find the linear magnification of the image produced. Solution. Object distance u is equals to 30 positive cm. Image distance v is equals to 15 cm positive. Substituting in this formula, 1 over u plus 1 over v equals to 1 over f. 1 over 30 plus 1 over v is equals to 1 over 15. Collecting like terms together, we have 1 over v equals to 1 over 15 minus 1 over 30. Finding the LCM, we have that 32 minus 1 all over 30, which is equals to 1 over 30. Therefore, v is equals to 30 over 1, which is 30 cm. Linear magnification m is equals to image distance v over object distance u, which is equals to 30 over 30, which is equals to 1. Therefore, the linear magnification of the image is equals to 1. Example 2. A concave mirror has a radius of curvature of 0.2 meter. If an object is placed 0.25 meter from the mirror, A. Find the distance of the image from the mirror. B. State the nature of the image. Solution. Using real is positive convention, R is equals to 0.25 0 meters, which is equals to 20 cm. F is equals to R over 2, which is equals to 10 cm. U, object image distance, is equals to 0.25, which is equals to 25 cm. If V is equals to distance of image from the mirror, and the mirror formula is equals to 1 over object distance plus 1 over image distance, V is equals to 1 over focal length, F. We now have 1 over our object distance, which is U, or which is 25, plus 1 over image distance, which is V, is equals to 1 over our focal length, which is 10, which is now equals to 1. We're collecting like terms, and we have 1 over V is equals to 1 over 10 minus 1 over 25. We have the LCM to be 50, and if you multiply 10, you divide 10 by 50, it should give you 5, and you divide 50 by 25, you get 2 minus 2. That is 5 minus 2 over 50, which will now give us 3 over 50. V is equals to, making V the subject of the formula, which is the image distance. We now have 50 over 3, which will give us 16.7 cm, or 0.17 meters. See, the image is real, inverted, and diminished. Refraction of light. Refraction is change in direction of light when it passes from one transparent medium to another. Snell's law. The ratio of the sine of an angle of incidence to the sine of angle of reflection, R, is a constant for a given pair of medium. This is known as Snell's law, and it shows that sine I, which is incidence, over sine R, which is the refraction, which is equals to a constant. Refractive index, N. This constant ratio, sine I over sine R, is known as the refractive index for two given media. Formula for reflective index, N. 1. N is equals to sine I incidence over sine R refractive. 2. N refractive index is equals to real depth over apparent depth. 3. Refractive index, N, is equals to 1 over sine C critical, where C is the critical angle, thus the reciprocal of sine of A. Critical angle is the refractive index of two given media. 4. Reflective index is equals to velocity of light in vacuum over velocity of light in a medium. 5. Reflective index is equals to sine I reflective over sine R, which is equals to sine A plus, in bracket, A plus D all over 2 over sine A over 2, where D is angle of mean deviation, A angle of prism. Example 1. If the angle of incidence I on an air-water boundary is 60 degrees, calculate angle of fraction R, taking reflective index N to be 4 over 3. Solution. Sine I over sine R is equal to sine 60 over sine R. N is equals to 4 over 3. Making sine R the subject of the formula, we now have 3 over 4 sine 60, which give us 0.6495. Getting the sine inverse to get the refraction, we have 41 degrees approximately. Example 2. Water is poured into a jar to a depth of 24 cm. The bottom of jar appears to be raised by 4 cm when viewed vertically. calculate the reflective index